Today we're looking at 6.5. You are a tortoise and I am a hare, and we are racing. Who wins? Well, that all depends. Let's take a deeper look at that. You say you will win because you're slow and steady, but I say I'm going to win because I have the speed. The distance from the starting line of the hare is given by the function d equals t squared. So automatically I'm going to come down here and write that next to the hare. Now, because our table is done in xy, if you want to rewrite it as y equals x squared to help yourself out, that's fine. So continuing on, because I'm so confident, being a hare and all, I give you 1 meter head start. The distance from the starting line of the tortoise, u, including the head start, is given by the function d equals 2t, 2 to the exponent t. So down here, d equals 2 with exponent t. Now again, because our table says xy, if you want to change this over to y equals 2 to the x, that's also fine. So now, our next instructions tell us to start both equations at -2. So when we plug this into our calculator, or when you plug each of those x values in, you end up with a table that looks like this. So for the tortoise, -2, -1, 0, 1, 2, 3, 4, and I like to add a 5 just to have a little more information. Those are the same numbers we're plugging in for the hare. So for the tortoise, if you plug in a -2, you're going to get out a 0.25. Plug in a -1, you're going to get 0.5. Plug in a 0, a 1, a 2, plug in 3, plug in 4, and then plug in 5. So we can go ahead and graph this on your coordinate plane. So at -2, it's a quarter, so it's barely above 0. And -1, it's half. At -0, it's 1, then 2, then 4, then 8. And your graph looks like this, which means this is an exponential function because it has that J curve. Also, if you look at the equation, x is in the exponent, so that is exponential. So for the hare, all week we've been talking about quadratic functions. When there's a 2, it's a u. There's a 2 in the exponent. That means this is a quadratic function. So the equation says we're going to square the x value. So -2 squared is 4. -1 squared, 1. 0 squared, 0. 1, 4, 9, 16, 25. So again, all I did was square the x values because that's what our equation tells us to do. So when I go to plot this on the graph, we have -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, 3, 9. So you can go ahead and see the parabola based on these ordered pairs. Remember, a parabola is a U shape, not a V shape. So make sure there's some curve down at the bottom to make that U shape. So then when we come down, it says, think about time here. Can we have negative time? No. Where should we focus our eyes on this graph? And that's going to be in quadrant 1, where your ordered pairs are positive, positive, because you can only have a positive amount of time. So it says highlight the two graphs in different colors. We'll inspect them further. So then it says if the race course is super long, like miles and miles, Who wins and how do you know? So if you look at our tables, we have that the tortoise starts off kind of slow. So the rate of change is not that quick. But at a certain point, all of a sudden, it's much further along than the hare. So is the hare ever going to catch up? No, the hare is not going to catch up. So because this is an exponential function, the tortoise would win in the long run. And that's because the distance is doubling. Which means it's exponential. So at what times are they tied? So if you look at your table, we have two instances where these graphs have the same number. So we have 2, 4, 2, 4. So they're tied at 2 seconds, and they're 4 meters along. Then we also have this 416. So at what times are they tied? At 2 seconds and 4 seconds. Both are at the same place. So they're tied. Instead of both, I'm going to put they are tied. Okay, so if the race course is 15 meters long, who wins, you or me? So we need to graph this on this other graph to help you guys see it a little bit more clearly. So when we have this graph, the first thing I want to do is change our scale factors. So 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. And that's because our graph won't give us much if we don't have that extra space. So for the tortoise, because the negative values do not make sense, we start at the 0. So 0, 1 is our first ordered pair. And then 1, 2, 2, 4, 3, 8, 4, 16. And draw your exponential function from there. So for the hare, again, the negatives don't make sense, so that part of our table we're going to forget about for now. So we have 0, 0, 1, 1, 2, 4, 3, 9, 4, 16. So if this race is only 15 meters long, that means we are looking at this area right here. Because I hit the blue line first, that means it took less time than the red line to reach that point. So in this case, the hare would win the race because it takes the hare less time to go 15 meters. So our next page is talking about these intervals of time. So what this 0 to actually means is from 0 to 2 seconds. So this interval of time 2, 4 is from 2 to 4 seconds. And this 4 infinity means we're going to go from 4 seconds to the rest of time. So to eternity. So if we look at from 0 to 2, The tortoise at this point has only gone, so our 0 seconds, the tortoise was 1 meter along. At 2 seconds, the tortoise was 4 meters along. So we're going to set this up in our slope formula. So we have x1, y1, x2, y2. So y2 minus y1 over x2 minus x1. And that formula is straight from your formula sheet. So 4 minus 1 is 3. 2 minus 0 is 0. 2 minus 0 is 2. So now we simplify that fraction. 3 divided by 2, and we get 1.5 meters per second is how fast that tortoise was going from seconds 0 to second in the first 2 seconds of the race. So the hare was traveling at 0, 0, and at 2 seconds it was 4 meters along. So when we do the same thing, x1, y1, x2, y2, and do your y2 minus y1 over x2 minus x1, you end up with 4 over 2. 4 divided by 2 is 2 meters per second, which means at this point the hare is faster. If we look at the next one, from 2 seconds to 4 seconds, so at 2 seconds, the tortoise had gone 4 meters. At 4 seconds, the tortoise had gone 16 meters. So when we set this up, we have x1, y1, x2, y2. So y2 minus y1 over x2 minus x1. We have 12 over 2. So that means from 2 seconds to 4 seconds, the tortoise was going 6 meters per second. At 2 seconds, the hare had been 4 meters. At 4 seconds, the hare had been 16 meters. Those are the exact same numbers as the tortoise, so I don't have to recalculate that. I already know that it's 6 meters per second. Now, from 4 seconds on, the tortoise is going to be ahead because it's an exponential function. So if you look at your graph, you'll notice that the slope of that line, the steepness of that line, is far greater than the steepness of the quadratic function from 4 seconds forward. So rate of change is another phrase for slope. And the way you find slope is your rise over run, which is the y2 minus y1 over x2 minus x1. So looking at these two graphs from 0 to 2.5 seconds, that's from here to here. Which one has the higher rate of change? It's going to be the linear one because it's higher on the graph. Their average rate of change would be the same, but since it just wants to know the rate of change between those 2 seconds, it's higher. So then it says which one has the higher rate of change after 2.5 seconds, and that would be the exponential because it's increasing faster than the linear.